And this could look like this. Although you see more than one thing in here, it's still only one term. Yes?
Mm-hmm.
Then we have something that has two terms, and it could look like this. And you see how it has one term and two terms, and we call this a binomial.
Binomial.
Very good. Now, can you imagine if it had three terms in it?
Trinomial.
It actually is. Trinomial.
One term, two term, three terms, and we call this a trinomial. So we have a monomial, binomial, trinomial.
So would that make four quadrinomial? Quadnomial.
Well, it would be quadratic.
Why?
Quadnomial? What do you call it? Go ahead.
I don't know.
Okay,
we just
well,
call it polynomial at that point.
It's called a polynomial at that point. Okay. Terms are separated from one another in an expression by a plus or a minus sign that are not within symbols of inclusion. So here we have separated the terms of the binomial and the trinomial, right? So I could separate it like this. Here's the first one. Hey, guess what symbol is right in front of the A? Great. And then what symbol is in front of the B? So I could say positive A, negative B. Yes?
Mm-hmm.
Okay. On this one, what's sitting in front of this 3x? Because this is one term. Yes?
Mm-hmm.
What symbol is sitting in front of him?
Positive.
Positive. Positive 3x squared, positive 4, negative 2c.
That's
Yes?
three different ones.
I've got
The
three
trinomial.
terms, and it's called a trinomial. Very good. The other thing that we want to talk about is we want to talk about what is sitting in front of this A beside the plus sign. I'm going to move the plus sign a little bit. When I say A squared, how many A's are there?
2.
8 times A.
No, there's one A. See the difference between 3x squared and A squared? So forget about the squared for a second. Forget about the squared. Let's take any like x plus y. How many x's?
1.
How many y's?
1.
So when you see a term and there's nothing sitting in front of it, he's just an x all by himself. There's two assumptions you can always make about him. You make that he has how many? What's the number in front of him?
1.
And what's the sign in front of him? Plus. He's always got a plus 1 sitting in front of him. Now you ask, why does that matter?
Because like when you have like 4x, then you multiply.
Yes, because 4x squared, this says that I have 4 x's and they're all squared. Yes?
Mm-hmm.
Yes? Are you with me? Okay, so that is the difference between these two things, and that's why this guy over here does not mean I have 2 A's.
It just means
Because 2 A's would be A plus A. I have 2 A's. A squared doesn't mean I have 2 A's. A squared means I'm going to take A and I'm going to multiply it by A.
so there's only one A in the.
Well, no, there's as many A's as there are A's. So if A is 2, let's say 8 is 8. Then I have 8 8s. I have 8 8s.
Given
Instead of 2A and A is 8, then I have 8 plus 8. That is that. That is that. When A equals 8. Yes?
Mm-hmm.
When I say 2A and A equals 8, that means there's 2 A's, or 2 times 8.
So you're saying
When I say A squared, I'm saying A times A, which means 8 times.
so if A equals 8 and there's 2 A's and there's like 8 8s because they equal that, there's only, you said there's only one A.
Well, there's only one A on the front
Okay,
side.
so
of
it doesn't-
instead of here.
okay.
When we're adding how many A's there are, this is how many times we're going to add itself
Okay.
together. This is how many times we're going to multiply itself together. Okay, so we're going to play with this a little bit more, and it's going to make more sense.
So 1 A
Okay.
squared.
1a squared. That's correct, Jordan.
Okay, you ready? We also want to talk about collecting like terms. So if I have 3x, where was I? 3x plus y plus x minus y, right? Well, I don't have values for my x's and y's, but I can still collect like terms. So what are the terms that are similar? So I look at this 3x. Is there anything that's similar to that?
X.
X. So this guy is similar. So I could say 3x, and he's got a plus on the front of him, right? And I've got another positive x. So how many x's do I now have?
2. Well, 4.
Why would I have 2? I have 3x, and I'm going to add one more x.
Yeah, let me do 4.
Okay, so 4x. And now I've got a plus y and a minus y. So how many y's do I have? I had one, and I'm going to take one away.
So it's a 0.
I have 0 y's. So my answer just is
4x.
4x. It doesn't matter what y is. I can stick a number in here to feel what it's supposed to be. If I made y 4. Plus 4 minus 4, I'd get 0. So I can put a 0 there. But I don't need to. Yes? Example number 2. Could you read it to me?
Collect like terms in the
Just
algebra.
read me the problem. It says
X,
at the very time, it says
3x plus 2x squared
2x squared
plus 4
plus 4
plus x squared
x squared
minus x
minus x
minus 1.
minus 1.
Yeah.
Okay, so when I look at this, first of all, how many terms do I have originally?
1, 2, 3, 4, 5, 6.
Great, I have 6 terms, but I have some terms that are like each other, and so I want to consolidate those
8.
terms. So my first term here is,
X
my first term
is 3.
is, no,
3x.
3x. So 3 is not the first term, x is not the first term. When we look at this, and I'm going to give you just a little bit more information because it might help you. When I look at something like 3x, it's one term. Inside the term, I have a coefficient and a variable. I have the number and then the unknowns. But the whole thing is the term.
So you're saying if I had just 2 plus 2, there's no terms because you need a variable and a
No,
coefficient.
if I had 2 plus 2 and I was combining like terms, well, first of all, I have 2 terms.
Okay.
I'm going to combine like terms. I'm going to get 4. My answer only has 1 term.
Okay.
This is still a term. It's only a coefficient, meaning it's only a number. It doesn't have any variables to it.
So
Go ahead.
you just said 2 and 2 were terms, and then
Yes.
you said, so isn't that?
There were 2 terms in the problem. There's 1 term in the solution.
Oh, okay.
Because I combined the like terms.
Okay.
Did it make sense?
Yes.
Okay, great. So let's go back now. Our first term is 3x. Can you sit up and pay attention? 3x. Are there any other terms that are like this one?
There's 2x squared and x squared and x.
No.
What are the like terms?
So this is where it gets a little tricky. X squared is different than x. So these guys are similar, and these guys are similar.
So
But
they're
these
different.
guys are not similar. They are not like terms.